Hello and welcome to the 6th in a series of videos aimed at developing retro games in vanilla JavaScript, using the canvas element. My name is Anthony, and please join me in my corner of the web, where I like to build stuff in the browser with the latest technologies. So, control systems. Is a game really a game if you can't control your character? Especially for a fighting game like Street Fighter. Our current code has a way to control fighters in the shape of a form, but is it a game yet? I'll be honest, these are a lot of questions for an intro, so I'll stop failing at trying to be philosophical and discuss what we'll be implementing in today's video. Well, we'll be looking into control systems, funnily enough. Our form has done a stellar job until now, but hopefully by the end of the video our fighters should be fully controllable from both the keyboard and gamepad devices connected to the machine. This is obviously fundamental to what we're trying to achieve, and is one step closer to making our code feel like a proper Street Fighter game. Once these are in place, we can finally proceed on to adding collision and attacking moves. So yes, today's video will be looking to flesh out a basic control system using various browser events and APIs, which I'll attempt to shed some light on. Starting from this video though, I'm going to introduce the dreaded to-do list. This list contains all the things we could possibly want to implement by the end of the video series. Now that's not to say I'll get them done or the list is complete, however. That will depend on the interest of both myself and the viewers watching these videos, I guess, as to where we end up. I will be crossing the items off the list as we complete them, however, and for today's video we'll be looking to cross off these 4 items. But as you can see, we still have quite a list of things still to complete, so it's probably a wise decision to jump back into the code and crack on to see where we end up today. Picking up exactly where we left off in our previous video, we had Ken and Ryu being controlled by a form above our canvas. This finally allowed us to enable multiple moves outside of the standard walking cycle, where we'd move back and forth across the screen. This method actually works just fine, and is a great way to demonstrate states and animations, flipping between them as necessary. We could actually continue to add further moves this way, but ultimately that's not what we're here for. We're aiming for similar behaviour and gameplay to that of the arcade. So to progress, this means we'll be looking to add a proper control system, and unfortunately, we're going to have to wave goodbye to our form. So let's jump straight back into the code and do just that. Starting with the HTML file, removing the form element and its children, along with the main tag that wraps our canvas element. We'll also remove any unnecessary CSS we've added too. Next, we'll go into the index file and remove the now redundant populate move drop-down function, not forgetting its call in the event listener. We also no longer need the fighter state import either, so we'll remove that reference too. And lastly, in the Street Fighter game class, we'll remove the submit event listener and its event handler function. Okay, that should be everything. So let's quickly make our first check of the video to ensure we've not broken anything, and it looks like we haven't. Both Ken and Ryu are stuck in their initial idle state without any way to transition from it. So let's look to fix that by adding some keyboard controls. Back in our code and the Explorer window, I'm going to add a new file in the source folder and call it inputhandler.js. This module will house all the code related to our control system. To retrieve keyboard input from within the browser, the most obvious answer is to use the key events that it offers us. And yes, that's exactly what we'll be doing here too. As this is a module, we'll create a new exported function and call it register keyboard events, and then add the key down event listener to the window object. As you'd expect, this will fire a keyboard event every time a key on the keyboard is pressed down, when within the current window. In regards to the actual handler, for now we'll just add a simple function that logs out the event to the console window, as we should probably have a look at what the event object includes first. But just before we can do that, we'll first need to add a call to this new exported function. So in the Street Fighter game class, we'll jump to the start function and make that call there. VS Code will hopefully be kind enough and automatically import its reference for us too. The idea here is that we'll register the keyboard event listeners when the game starts. Okay, back in the browser then, we'll open up the DevTools and see what we get. Every time we press a key, the event is logged to the console as you'd expect. Opening up one of these events shows quite a few properties, some standard ones and some very specific to the key event itself. What we're personally interested in is knowing which key it was actually pressed, and we have a couple of options for that. Amongst the list that is provided, people tend to focus on the code, key, key code and even which properties. The one we should actually use though is the code property, as this is universal across all keyboards and locales. The others are either now deprecated or changed depending on the keyboard language used. Okay, so far so good. But if we go back to the window and hold our key down, you'll notice that after a certain amount of time, the event keeps on firing. This behaviour, unfortunately, is due to how your OS handles repeated key presses when a key is held down and will cause us problems. So with this knowledge, let's go back to the code and attempt to handle this correctly. In the new input handler module, we'll remove the key down event handler function and extract that out to a new function called handle key down. We'll also replicate that with the key up event listener, which, as you can probably expect, fires the exact same event as the key down event, but when the key is released. This event will call its own function called handle key up. Next, we'll add a new variable called held keys and assign it to a set object. This will be used to hold the unique set of keys that are currently being held down. So in the handle key down handler function, we'll add the keyboard event's code property we saw earlier to the set object, and likewise, in the handle up key function, we'll remove the keyboard event's code property from the set object. This means we can now query the held keys variable at any time to see if a certain key is being held down. Before we can continue, however, we will need to add a quick call to the event's preventDefault function in each of our keyboard event handler functions. This is required to block any default action that the key press might have within the browser, and allows us to override it with our own game code. The downside to this, unfortunately, is that it will block any default action from any key press within the browser window, which can cause us some annoyances. For example, if we want to refresh the page using F5, or open the DevTools with F12, it wouldn't be possible, as we're currently preventing that default action. We'll come back to this later, but for now, this is fine. To help us use the held keys object, we'll also add two more little helper functions, called isKeyDown and isKeyUp, which will simply check if a certain code exists within it. And with that, we now have our basic keyboard functionality complete. But how do we test it? Well, let's go ahead and update some of our fighter state functions. So let's go back to our fighter class and have a look at our state machine again. If you remember from our previous video, we have a property for each state called update. This property is a function that handles the logic for that state. Let's look to get the forward and backward movements working again by assigning an update function to those states. This time, however, the logic will be based on keyboard key presses. As we know, the initial state for the fighter is set to the idle state. We'll look to add an update function there, so we can transition from this state to the walk states when a key on the keyboard has been pressed. We'll add a new function called handle idle states, and then map that back to the state machine's update property for the idle state. We'll also do the same for the walk forward and walk backward states by adding back the handle move forward states and handle move backward state functions, and mapping those back to the state machine too. With our functions set up, let's add a couple of checks for the keyboard. I'll be using the arrow keys as that's generally what most gamers would naturally expect to use. This does raise the question though, how do we know which codes we need to use? Well, there's actually a very handy site from Total which will give you all the key information you'll probably ever need. Simply press a key and the page will update with the necessary details. I recommend you ignore the large number in the middle of the screen however, as this is the key code which is actually now deprecated. As mentioned previously, for this tutorial series, we'll only need to use the event code box directly under the number. As an example, if you wish to use WASAD or something else for your primary directions, this site will allow you to get the required codes for those keys. For me, however, I'm going to press each of the arrow keys in turn to collect the codes I require. Doing so shows that all the codes are prefixed with the word arrow, followed by the direction name. Either way, maybe you'll find this site useful for other projects too. Okay, back in the handle idle state function, we'll use the isKeyDown function from our input handler module and check for the arrow left and arrow right codes. If the left arrow key is within the held keys set object, we'll change the fighter's state to walk backwards. Likewise, we'll do exactly the same for the right arrow, but this time change the state to walk forward. So with those changes, let's see what we've accomplished so far in the browser. Well, it seems we do have an issue unfortunately. Our fighters do move as expected, but just like the form in the last video, the characters stay in the transitioned movement state, even when the arrow keys are released. Although, if we want to replicate the arcade game, we really want to reset the fighter back to the idle state if this happens. In the handle forward state and the handle backward state functions, we'll check to see if the arrow key has been released, using the other helper function we created, isKeyUp. If so, we'll transition back to the idle state. Another quick test in the browser, and huzzah! The fighters are actually moving correctly for the first time based on the keyboard controls. The code we have right now is working out just fine, but we're having to use hard-coded key code strings within our fighter state logic. As we'll be checking for key presses multiple times throughout our fighter states over the course of this video, this will start to become a little cumbersome. So before we rush ahead, there's a couple of things we can do to help us abstract the hard-coded keys from our code. Let's go ahead and add a new file to the constants folder and call it control.js. Here I'm going to add a new enum object called control and add all 4 of the possible directional controls as properties, this being left, right, up and down. This object will eventually contain all the standard controls for a Street Fighter game, but we only need these for now. As this enum defines the controls available to our fighters, let's also add another object that we'll use to map the actual keys to these controls. Until now, we've been moving the fighters together as a pair, but I think it's about time we started to move them independently, just like the actual arcade. So I'm going to call this new object controls and make it an array. In this, we'll have 2 objects, the first being the first fighter's controls, and the second for the second fighter's controls. We'll add a property called keyboard, which funnily enough will house the keyboard controls. In this, we'll add each of the control enum keys as properties, and then assign the actual key codes we want to use to that particular direction. Let's do the same for the second object and map the keys for the second player. As mentioned previously, we'll be using the arrow keys for the first player, and for the second, I'll be using the default keys assigned to the second player in the MAME emulator, which are the D, G, R and F keys. By all means, you can use whatever keys you prefer here. With our keyboard controls now configured, let's move over to the input handler module and get it to use this new definition. Let's add a helper function for each movement direction, which will take an ID as a parameter. This ID will map to the controls object we just created and is the index for the array, which we know will be the identifier for the unique player or fighter ID that has its own set of keyboard controls. Each of these helper functions will simply wrap the isKeyDown function that we used before, but using both the ID and the controls constant object to check the correct key is pressed down based on the control enum. Unfortunately, VS Code decided to mess up the input this time, so let's just quickly fix that before moving on. Okay, back in our fighter class, we'll now have to add a new constructor argument so we can identify which player ID they have been assigned to, which we know has to be either 0 or 1 based on our controls array index. So we'll add a player ID at the end of the parameter list and then assign it to a local property for that class. As we've now changed the contract on the fighter class, we'll also need to fix both the Ken and Ryu classes so that they also forward on this new argument. It seems Ken still has a velocity parameter instead of direction, so we'll fix that too while we're here. We're building quite a list of constructor parameters now, but not to worry, we'll look to refactor some of this in the next video, when we start fleshing out the almost forgotten stage class. The last change we'll need to make is for the player ID, which will be in the Street Fighter game class, where we initiate both the Ken and Ryu classes. We'll give Ryu an ID of 0, making him the first player, and then give Ken an ID of 1, making him the second player. So back in the fighter class, we'll first remove the current isKeyDown and isKeyUp imports from the input handler module, and import everything using a namespace import instead, and call it control. This way, we'll get access to all the exported functions within the module, but they will be mapped to this control variable. Let's now go ahead and move our keyboard checks over to the new directional helpers. Wherever we've used arrow left, we'll swap that with the isLeft function, and where we've used arrow right, we'll swap that with the isRight function. Notice how we are passing on the player ID into each function, so we know which control set and key has been pressed. Checking the result in the browser, and we again have another first. Both Ryu and Ken can be controlled independently using the keys we set up and configured within our controls constant object. But unfortunately, we found another issue. As Ken is facing the opposite direction, the movement is in reverse. This is a little annoying, but thankfully is quite a simple thing to fix. Back in our input handler module, we'll again add 2 more small function helpers, called isForward and isBackward, which will take both an ID and direction as arguments. So depending on the player's direction, we'll map this to the correct isRight and isLeft keyboard event. Okay, in the fighter class, we'll again just swap out the necessary isLeft and isRight functions with the correct isForward and isBackward functions instead, remembering we now need to pass in the directional property too. With another quick check in the browser, Ryu is still working as before, but now Ken also has the correct keys mapped based on his direction. Nice. Okay, let's move on to another state and get the jumping working next. In the handle idle state function, we'll this time check to see if the isUp function is true, and if so, change the state to jump up. Within the handle walk forward state, we'll do the same, but as we're moving forward, we'll transition to the jump forward state instead. Likewise, in the handle walk backward state, as we're moving backwards, we'll transition to the jump backward state. And honestly, that's all we need. So with another browser check, we're now able to jump around the screen at will, both from the idle state and while moving. One little problem we do have at the moment is that we're unable to jump forward or backwards from the idle state however. Not to worry, we'll look to fix this in the next video, when we introduce a new state to our fighter's state machine. Okay, so we're currently only missing the crouch state from the available states, so let's look to do that next. We'll first need to add the necessary state functions, as we're currently missing a couple for the crouch states. So we'll first add the handle crouch state and the handle crouch down init functions, and map them back to the state machine. Okay, with the crouch state now set up, let's add the keyboard controls. In the idle state function, we'll add a new keyboard check with the is down function, and change the state to the crouch down state if the key is pressed down. We'll copy this check to both the walk forward state and the walk backward state functions, as we know we should be able to crouch while moving too. However, as we are able to crouch while moving, we'll also need to reset the velocities that are currently in motion. So in our handle crouch down init function, we'll make a call to the handle idle init function, as we know that function does this already. Note to self, we may want to extract that functionality out to a more suitable function at some point. Okay, with that complete, let's go back to the browser again and see where we are. Both Ken and Ryu are now able to perform their crouch moves, either from the idle or walking states as we anticipated. We should now have all the states linked to the keyboard controls that we had in the previous video from within the form. As we did all the prep work in the previous video with our state machine, hopefully you can see how easy it has been to implement the keyboard controls and the advantages the state machine has provided. Before moving on to adding gamepads, I'd like to take a slight detour and add something that we've been missing for quite a while now, and that is the fighter's shadow. So just like in the previous videos, we'll first need to source an image we can use. Heading over to our trusted Spriters resource site again, the best I could find for this was from Akuma's sprite sheet. It has various shadows baked into the sprites themselves. So just like before, let's right click and copy the image and then paste it into our graphics tool. Scanning over the image, there are quite a few sprites we could use as a reference. But we need to get a shadow that matches the idle state. As all of the frames have at least some of Akuma's feet overlapping the shadow, I settled on using a couple of the high kick sprites, deciding to take part of the shadow from one sprite and combining it with another to get the full image. Once done, I cropped the image to the size of the shadow, set its colour to black, and ensured the background was set to transparent again. Once I was happy, I saved the final image as shadow.png into the images folder alongside the other images in our project. And just as a final check, we'll just view the file within VS Code to confirm we're in a good place to move forward. Okay, the idea here is to create another entity for the shadow, so just like before, we'll need to add an image tag to our HTML file so that the image can be loaded and be available for us to use in the game. We'll give it an alt attribute of shadow too, so that we can reference it in the code. Next, we'll add a new class within our fighters folder and call it shadow.js. We'll continue to create its class structure along with its constructor. In regards to the constructor, we'll need to reference a fighter object so that the shadow can shadow it. We'll create a local property called fighter and assign it to that. We'll then obviously need an image property so that we can bring in our image data. We'll again use a query selector to find the new shadow image element within the DOM. And lastly, we'll add a frame property to contain our frame and origin data in the same format that we used in our Ken and Ryu classes. As this class and object is going to be another entity, we'll also need to follow its contract and add both the update and draw functions too. The update function will be empty for now, but we'll need to populate the draw function in the same way that we've done with the fighter class, in that we first deconstruct the data from the frame property and then use it to draw the image to the canvas using the context we'll forward on. In regards to the position coordinates of the draw image call, for the X position, we'll just use the fighter property's X position, as we want the shadow to always follow the assigned fighter on this axis. But for the Y position, this will always be fixed to the floor. We know we have a constant for that already, called stage floor, so let's import that and use it for the Y position. We'll again use the origin points in the frame properties array to offset the image to ensure it's centered correctly under the fighter. And lastly, we'll wrap any values that cause a decimal place with a map floor function to prevent any anti-aliasing. And that should be enough for now. So back in the Street Fighter game class, let's look to add a shadow for both Ken and Ryu to the main entities array in the constructor. We want to do this above the fighters location to ensure that they're drawn first and therefore behind the fighters themselves. Rather than create them individually, I've used a map of the fighters array here to instantiate the shadow's entities. This way we can pass in the fighters reference too. And with that, let's see what this looks like in the browser. It seems the shadows are working fine. They are positioned correctly under the fighter and move correctly with their movements while staying on the floor. That said, it's a little too black for my liking though. Also, if you were to compare this to the original game, the shadows seem to shrink when the fighters jump up in the air, to give the effect that there is distance between the fighter and the floor. It also seems to use multiple images to produce this. We, on the other hand, are able to do this much easier with a single image, with a little help from the context scaling and alpha effects. Back in the shadow class, I'm going to add a new scale variable, and add a little calculation that we can use to shrink the image based on the distance of the fighter from the floor. As we've learnt in the previous videos, the draw image call has a set of destination coordinates which can be used to deform the source image. So let's do that here and apply the new scale variable to the destination coordinates. Again, ensuring we wrap the values within a math floor function to prevent any anti-aliasing. Next, we're going to introduce a new context property called global alpha. As the name suggests, it's an easy way to apply a global alpha effect to all the context draw calls. It takes a decimal value between 1 and 0. A value of 1 makes all the pixels fully opaque, whereas a value of 0 makes all the pixels fully transparent. We'll settle right in the middle and use a 0.5 for a half transparent image, allowing enough of the background to show through. As this is a global property, just like the scale function we used previously, we'll need to reset it back after we're done, otherwise any further calls will continue to have the same alpha effect applied to them. So we'll use the same global alpha property again after the draw image call, but with a value of 1 to ensure it's now fully opaque again. Another quick look in the browser, and the shadow is now semi-transparent and resizes correctly when the fighters are in the air, which acts in the same way as the original game, but is much more smoother in our version. I suppose this is a win for us on that one. Okay, with the shadow now finally in place, let's get back to adding the gamepad controls. We'll start back in the control constant file, as we'll need to set up and configure the gamepad controls first, just as we did with the keyboard controls. We'll add a property called gamepad above the keyboard property, and again copy its structure using the available properties in the control enum. We'll reset the values though, as gamepads work very differently from the keyboard. With keyboard input, we use event listeners just like any other events in JavaScript to capture the necessary values we need, as and when they happen. However, the Gamepad API found in modern browsers unfortunately does not work this way, at least currently. The browser has a special gamepad function that returns an array, which contains a snapshot of information for the gamepads that are connected to the machine. Let's delve into this special function a little and see how it's structured and what it offers us before continuing on with the code. Back in the browser, I'll open up the DevTools and the console window once more. The function in question is attached to the navigator object and is called getGamepads. When calling this function at the moment, however, it will return an array with a set of no values, even though I have two gamepads physically connected to my machine. This is actually by design and is a security feature. Basically, if you call the getGamepads function, the browser won't initially be able to access your gamepads. You'll first need the browser window to have focus, and for a gamepad to have been touched, meaning you'll either need to press a button or move one of the thumbsticks. This will then grant the browser to acknowledge them. So let's go ahead and test this. I'll first click on the game area so that it has focus, and then on the first gamepad, I'll press one of the buttons to wake the browser up. Now if I call the getGamepads function again, you'll notice the browser now correctly identifies that I have two gamepads, as the array has two gamepad objects this time. Okay, let's open the first object and see what we have to play with. The main properties of interest are both the axes and the buttons arrays. These contain all the current states of the thumbsticks and buttons available on the gamepad. Just for reference, I'm using two Xbox 360 controllers, as detailed in the ID property. A word of warning though, if you're using other controllers or gamepads, some of the details here, and possibly the code that follows, might be slightly incorrect, as they could have their own unique axes or button setups. That said, the majority of the information should mostly be the same, but some of the code might need altering somewhat to suit. The axes properties usually represent the X and Y values of analog controls, such as thumbsticks, ranging from -1 to 1, -1 being fully left or up, and 1 being fully right or down. A value of 0 should mean the stick is neither one nor the other, but as the thumbsticks generally have a dead zone, the values will float around 0 but never actually be it. With the indexes themselves, this varies widely from gamepad to gamepad, but for standard Xbox 360 gamepads, indexes 0 and 1 are the left thumbstick values, and 2 and 3 are the right thumbstick values. The first index in the group is the horizontal value, and the second index is the vertical one. So for example, if I were to hold the left thumbstick all the way to the left and run the getGamepads function again, in the axes array for index 0, you'll see that we now have a value of -1. Moving on to the buttons, each button has its own index and a gamepad button object. If we were to open one of these objects, you'll notice that there are 3 properties, but the only one of interest today is the press property. As you can expect, this is a boolean value and presents whether a button is physically pressed or not. The other properties are out of scope for this video, but I may come back to these in another tutorial in the future. So to test this, I'm going to press down the A button on the first controller, which I know is button 0. Then, while pressed, run the getGamepads function again. Opening up the first gamepad object, and then the first button object, we can see the press property is now set to true. As we're ultimately looking to collect a set of controls with a constant file, continuing to work this way will be incredibly time consuming. Ideally, what we need is a tool that provides some instant feedback for the gamepad's changes. And funnily enough, there's plenty on the web, but I personally find Gamepad Tester to be one of the better ones. Just like before, we'll need to press a button on the gamepad before the site will recognise it. But once we do, the site will reveal a visual presentation of your gamepad, along with a summary of all the buttons and axes. If we were to use the gamepad, you'll notice the UI will update along with it, showing you which buttons you pressed along with their indexes, and for the thumbsticks, its decimal axis value. We'll possibly come back to this site in a later video, once we need the actual buttons for the attacking moves, but for now, we're only interested in the thumbstick values and the directional pad, which are also identified as buttons. While looking at the UI, our buttons 12 through to 15. So back in the code, we'll update the constant file and add the necessary button IDs for the gamepad object, mapping the correct direction to the correct button. As I'm using an Xbox 360 controller for both players, the button IDs will be the same for both player 1 and player 2, so I'll just copy the same values over. With that configured, we'll also need to add a couple of unique properties for the control thumbstick too. We'll add a new enum object called gamepad thumbstick for this. As we've learned, gamepads have separate axes for horizontal and vertical directions, so we will require two properties to store which axis indexes we'll use. We'll call them horizontal ax ID and vertical ax ID. We'll also add a dead zone property too, which will allow us to configure a threshold for the ax values. Back inside the gamepad object, we'll add these new thumbstick properties and configure them to match the axis for our personal gamepads. For myself, I know the Xbox 360 controller's left thumbstick has an horizontal ax ID of 0 and the vertical ax ID of 1, so I'll add those, but you may need to alter them to match your gamepad's configuration. I'll also add a dead zone value of 0.5 for now, but if required we can play around with that later. As I know my second gamepad is also an Xbox 360 controller, I'll copy the value over to the second controls object too. Again, you can configure as necessary. And that's all the gamepad configuration done for this video. As you probably noticed, the controls object currently needs to be configured manually in code, but if there's enough interest, I may expand this to be a fully configurable object that we can set up in-game in a future video. The next step at the moment, however, is to set up our input handler module to now recognise these new control properties. So back in that file, we'll first need an object to store a snapshot of the current gamepad information, similar to the held keys set object. This time, however, we'll create a new map object and call it gamepads, as we'll need to hold the unique gamepad ID as the key. Next, we'll add a new function called registered gamepad events. Here we'll add two new event listeners for the gamepad connected and gamepad disconnected events. As you'd expect, these events tell the browser when a new gamepad has either been connected or disconnected from the machine. We'll add a callback event handler for each and call them handle gamepad connected and handle gamepad disconnected, respectively. Both of these events return a gamepad object for the controller that has caused the event, in the same object structure as the getGamepads function. We'll use these events to keep a list of the current connected gamepads, which we'll maintain in our local gamepads object. So, with that in mind, in the connected event, we'll take its axes and buttons array and store an entry in our local gamepads map object, using the index as the key. In the same way, we'll use the index to delete the entry from the gamepads object when it disconnects. The indexes we're using here should match the player's indexes we've set up earlier, and map nicely to our controls constant object too. As we know the getGamepads function constantly updates in the background, we'll need another function that will poll this data each frame, so we can update our local gamepads map object. So let's create another function and call it pollGamepads. In this function we'll iterate over the getGamepads data within a for loop and compare it against the indexes we have in our local gamepads map object. If it exists, we'll update the entry with the laser's axis and buttons details. As we know the function returns nulls, we'll also add a quick check to ensure we skip any of those entries. Okay, the last step now is to add these calls to our Street Fighter game class. In the start function, we'll add the registered gamepad events function alongside the keyboard events call. As for the pollGamepads function, as we'll need to update the gamepad data every frame, we'll naturally put this within the frame function before the update call to ensure our entities have the latest data available. And with that, the game should now be configured to use gamepads. If we were to check the browser and move one or more of the gamepads, opening up the DevTools and putting a breakpoint on the poll gamepads function within the input handler module, you'll see the local gamepads map object has the necessary gamepad information ready for us to use. So the last step is to add the helper functions, similar to how we did with the keyboard controls earlier in the video, but this time for the gamepad's buttons and axe values. Back in the input handler module, under the isKeyDown and isKeyUp functions, we'll add two more functions called isButtonDown and isButtonUp. These will take two arguments, a gamepad ID, which is the key stored in our gamepad's map object, and a button index. These functions work in exactly the same way as the keyboard functions, in that they will check if the button is pressed down or not, using the button's press property we looked at earlier. At the moment though, the only buttons we're currently interested in are those assigned to the directional pad. We'll again do something similar with the thumbstick's axes too, and create two further functions called isAxeGreater and isAxeLower. Both functions again take a pad ID just like the button functions above, but this time also pass in an axe index and a value. As we know the axe value can be between -1 and 1, we'll use these functions to check whether they are greater or lower than the value we pass in. Okay, with our base function helpers done, here comes the best part. We can now simply extend our directional helper functions that we set up for the keyboard controls below with these new gamepad helper functions, meaning we don't need to touch the fighter code for the game to recognise our gamepads. Let's update the isLeft function first to show what I mean. We'll add an isButtonDown and an isAxeLower function check after the isKeyDown function, and return true if any of them are true. We're using the isAxeLower function here, as we know the left direction of the axe value is negative and maxes out at -1. For the isButtonDown function, just like the isKeyDown function, we're passing in the controls constant, but using its new gamepad property. As for the isAxeLower function, as we're updating the left direction, we'll pass in the horizontal axe ID property from our controls gamepad property. We'll also now use the dead zone value as our threshold. So if the axe is lower than this value, it will return true. Let's do the same with the other directional functions too, by adding both the isButtonDown function and either a isAxeLower or isAxeHigher function depending on the direction. The isAxeGreater function works just the same as the isAxeLower function, but in reverse, so the dead zone value will also be a positive value. As for the isUp and isDown functions, we'll also use the vertical axe ID property from the controls constant object. Once done, this means regardless of which control device users are using, they are now able to swap and change between the keyboard and gamepad for the same fighter, at will if necessary, which is far more accessible than setting them up individually. Overall, this gamepad handling is quite basic, and could be fleshed out somewhat, especially to accommodate more generic controllers or for more than two controllers, but for this tutorial, the code that we have here is good enough as a base to extend upon, if anyone is interested to do so. So finally, let's see what the results are in the browser. If all is well, you should now be able to control either Ryu or Ken with their configured controls, either on the keyboard or the gamepad. Before we finish the video however, I'd like to come back to our preventDefault issue from earlier, so that we don't block any keys unnecessarily. Opening up the input handler module once more, we'll add a new variable and call this mapped keys. Here we'll map through our controls object and create a complete list of keyboard codes currently being used within it. With this new array, in each of our keyboard event handlers, we'll compare the event's code against this list. If the code doesn't exist, we'll simply short circuit and return early, before we prevent its default action. To quickly test this, we'll go back to the browser and press one of the F keys we mentioned before. Pressing F5 for example will now correctly refresh the browser page, and pressing F12 will now open the DevTools as expected. And just to confirm, we are still able to use the arrow keys to control Ryu as before. Okay, I think we'll leave it there for today, as the video is now starting to get overly long. Let's quickly review what we've learnt in this video. As we've now got the controls in, hopefully you'll agree that it's starting to feel more like a game now. However, there's still plenty to get on with, as there's still a few more things we need to get in before we can move on to the attacks, such as collisions or push boxes. I had planned to include those in this video, but as you can see, this video turned out to be the longest video I've done to date. So unfortunately we'll look to add those in the next part. This means the planned schedule for the videos will now slightly change somewhat. Hopefully though you've learnt something about game controls from this video, and if so, it's been helpful. As mentioned, the gamepad controls should work just fine, but could definitely be extended if anyone feels up to it. We may do some of that ourselves later in the series, but for now the code we have should be good enough until we look to add punch and kick buttons. As I had planned to talk about camera systems with parallel scrolling backgrounds in the following video, I may move on to hitboxes and therefore attack moves instead, as it seems to be what people are asking for. We will however need to add the status bar at the top of the screen, so we can implement the health bars and its timer first. Please let me know if there's anything you'd like me to focus on, or stuff you think I've missed so far though, as I'm always interested to hear what you think of my content. And finally again, I'd just like to thank everyone for the recent likes, subscribes and comments from these videos. I never assumed people would be interested in what I have to say. It really has surprised me. So with that, I'll say my goodbyes and hopefully see you in the next one. Ant out.